Hi, this is Mike Carter with Carter Custom Knives. I wanted to talk a little bit today about blade steel. And the truth is, the term blade steel in itself is a bit of a misnomer. The fact of the matter is that the cutlery industry is such a small portion of the steel that is produced today that the steel mills really don't put much effort into making specifically blade steel. Even though there's millions of knives made every year, most of those are for dinnerware, and they're, just stamped out of pretty low quality steel usually. But, to make a steel specifically for a certain knife application rarely happens. People can order a specific recipe that they want, just give them all the qualities they want in a blade, but if they're going to order 20,000 pounds of it in a certain thickness, and that just rarely happens. Truth of the matter is, most steels that we have found that are very good blade steels were simply adapted from steel that was made for some other purpose, a tool steel or a spring steel. And in many cases, it's just a matter of finding a particular steel and testing it, see what works well for a blade. And in some cases, it's just finding the right heat treatment for a blade. People like Gail Bradley and Warren Osborne and Scott Devanna have spent a great deal of time in experimenting and researching and testing steels to determine what steels, that are available today make good blade steels. And in some cases, the heat treatment that might be published by the manufacturer for one purpose may not be the right heat treatment that you would want for blade steel. A good example of that is a few years ago in the cutting competitions, people discovered CPM M4. Just an incredible steel for as far as getting it extremely hard, being able to grind it very thin. And this wasn't a new steel. This had been around for 30 years. But some people got experimenting with it and found the right heat treatment that made it work well for blades. And, a year or two later, everybody in the cutting competition was using M4. Now I'm sure they've moved on to something else. I've kind of lost contact with that, but that's just an example of it is a steel that was adapted from something else and used for blades. Now, I make all my knives from stock removal. In other words, I buy a bar of steel, the type of steel that I want, and I buy it in the thickness that I want. And I can get it in various lengths and widths depending on, what application what type of knife I'm making with it. And, there's a lot of misconceptions and myths about forging versus stock removal. Forging is nothing more than shaping steel. Getting it hot enough where you can actually move it around and shape it. And bar stock is forged at the mill. When they pour the steel and then roll it out in flat bars, they're forging it to shape. So there's really not any difference in the steel itself. Hitting it with a hammer doesn't, you can't beat goodness into steel. It's simply shaping steel. And years ago, you really didn't have much choice but to forge your steel because you couldn't get flat bar stock in the shape that you wanted it. So you took what you could get and you hammered it into the shape that you wanted. But now you can buy bar stock, virtually any kind of steel you want, any thickness you want, any width you want. And I buy, a lot of my steel from Admiral Steel. Typically, the bars will come in, 1.5, 2 inch widths and lengths anywhere from a foot to 6 feet. In some cases, for steel that I use a lot of, such as this 1/4 inch 440C, I'll buy it in 6 foot lengths, 6 inches wide. And some steels, such as this 3/8 inch thick 440C, I've only found one supplier that can provide this in the 3/8 inch thickness, and I have to special order this from California, so I'll buy longer bars of that. And in my case, I make a lot of large blades where the blade is 2 to 3 inches wide. So, you know, I just need to buy steel that is wider widths. And sometimes that dictates what steel is available to you. In some cases, you just simply can't find a particular steel in a width wider than about 1.5 inches. None of the distributors carry it in that width. So, you know, somebody wants a big Bowie knife, well, I can get 440C in 6 inch widths. If they want, you know, ATS 34, maybe I can only find that in 1.5 inch width, so that's not going to work for me. You know, steel is basically just iron with carbon added to it, and that makes steel. Stainless steel has chromium added to it. Anything that has at least 13% chromium is considered stainless steel. You have some steels such as D2, which is near stainless. It has a lot of chromium in it, but only about 10 or 11%, so it's not quite enough to be considered stainless. And while we're on that, I'll touch on, you know, just to be clear, stainless steel is rust resistant. It is not rust proof. Stainless steel will rust. If you leave it in contact with water, you put it in a wet sheath and leave it, it will rust. It just will not rust as easily as non-stainless steel. Now, steel is basically just iron with carbon added to it. And simple steels such as 1080, 5160 are basically just that, just iron and carbon, maybe a little manganese added to it. But that's why they're basically simple steels. They're just iron, mostly iron and carbon. Most modern steels today are complex alloys, especially the stainless steels, and they may have a lot of ingredients. I mean, all steel is going to have carbon, and for a good blade steel, you want somewhere between 0.5% to 1.5% carbon. Carbon is basically what gives the steel its hardness. Up to a point. Once you get past a certain point, then it just becomes too brittle to use as a knife steel. But blade steel, you know, around 1% carbon is what most good blade steels will contain. Now, for stainless steel, you have to have the chromium, and anything that's got, you know, at least 13% chromium is considered stainless. And stainless adds rust resistance and hardening abilities to the steel. Now, as I said, most modern steels are complex alloys with a very specific recipe, and they'll add things like manganese, which helps refine the grain structure of the steel. It contributes to the hardenability. Molybdenum is a carbide former. It's in a lot of blade steels. It helps prevent brittleness and helps with air hardening steels such as A2, ATS 34. Often they have nickel added, which adds to the toughness. Silicon contributes to the strength of the steel. Sometimes they have tungsten, which is a carbide former, increases wear resistance. A lot of the blade steels have vanadium, which contributes to wear resistance and hardenability. But all of these elements bring a specific property to the steel. And, you know, there are various combinations of different amounts of these elements, and that makes up the recipe for a particular steel. Now, another big advantage to buying steel in bar stock is, you know, these come from steel mills where, as I said, blade steel isn't their primary concern. They're making these for structural steel and tooling and different things, but they have to be very specific. The quality has to be very good. So they have a lot of quality control. The recipes are very exact. And so when you buy the steel, you know exactly what you're getting. You know exactly what's in it. And you know exactly how it's going to perform. And if you buy a particular steel from, you know, a steel mill where they've got all these quality control checks, you can count on it that if you follow that heat treating recipe for that particular steel, you're going to get the same results every time. You know, there's some variances. You know, you might find one batch of steel is a little better than another batch, you know, that just the way it was manufactured maybe just slightly different, but generally when you're buying bar stock, you know what you're getting, you know how it's going to perform if you follow the right heat treating recipe. Proper heat treating is the absolutely critical part of any good knife. If you don't do the proper heat treatment for the particular steel that you're using, you will not get the optimum performance out of that steel, and you may in fact ruin that steel. Every steel has a particular heat treating recipe, if you will, where you need to get it to a certain temperature. In some cases, particularly with the stainless steels, you have to get it to a very precise temperature, hold it at that temperature for a certain amount of time, and then quench it in a particular method. And then that's generally followed by a draw tempering process, which relaxes the steel, removes any stress points in the steel. And, you know, for instance, with 440C stainless, which is my favorite all-purpose steel, you have to take that to 1850 degrees Fahrenheit and hold it there at that temperature for 30 minutes. And then it's air-cooled. Just take it out of the oven and let it cool. And once it reaches room temperature, then you draw temper it at about 400 to 450 degrees, depending on what you want your final hardness to be. And I like them to, you know, when they come out, 440C comes out of heat treatment, it's about 60 or 61 Rockwell. I will draw temper those back to about 57, which I think is just a really good point at where it performs well, holds an edge well, but it's not so hard that it's really difficult to sharpen, or so hard that it might be a little bit brittle and chip an edge. You know, some of the simpler steels, carbon steels, you can simply heat them up to the point where they're non-magnetic and then quench them in oil or water. And quenching is nothing more than controlling the rate at which it cools. And I'm not going to get too technical into the molecular structure of the steels, but basically you're heating them up to where the carbon atom separates from the molecule, and you're quenching it. You're kind of freezing the molecular structure in the state that you want it. And quenching is nothing more than controlling that cooling rate and controlling where that molecular structure freezes. You know, water quenches them very fast. It's going to cool the steel very fast. there's a risk. Sometimes it's such a shock to the steel that it will crack. Most people, if you're using a water or an oil quenching steel, quench them in warm oil, which cools them rather quickly, but not real fast. The oil is at a certain temperature where it just cools it at a certain rate. With air hardening steels, obviously they're cooling much slower. But, they've learned that that's part of your heat treatment, that if it's done in a very specific way, specific temperatures, a specific quenching method, that's what's going to give you your optimum performance out of that steel. Now the steel, when I buy it from the mills, I buy it in the annealed state. It's generally hot rolled through a series of rollers until it gets down to the thickness that they're producing at that time. And it's annealed where it's heated to a certain temperature and allowed to cool slowly. And in the annealed state, the steel is relatively soft. It's easier to work. You can grind it, you can drill it, and cut it fairly easily. After it's hardened, you can't drill it. It's as hard as your drill bit. So that's what the heat treatment makes the steel hard and stabilizes it. And also, at the mills, they put it through a pickling process, which they put it in an acid bath to remove the mill scale that forms on the surface of the steel. And the pickling leaves kind of a pitted finish on the steel that often has to be ground out. Now you can also buy your steel in precision ground bars that pitting has already been ground out. It gives you a very smooth, clean surface to start with. And another thing you'll find with precision ground steel, most steels, if you're buying the annealed, these are just rolled out in big sheets and then sheared. A big shearing blade just literally cuts it into different sections. And with the shearing process, you can probably see there's a slightly rounded edge. These edges aren't real square. So when I'm cutting this and profiling it, I would have to put that against the disc grinder and square that edge up. You'll find on precision steel, you do have the very sharp, square edges. So that's another consideration when you're buying bar stock. Do you want to spend the time surface grinding it to get that pitting out of it, get a good clean surface, or you want to spend a little bit more money and have that already done for you? Now when you heat treat steel, there's also a decarburization process that will occur. Anytime you heat steel above about 1300 degrees Fahrenheit, there will be some decarburization where the carbon atoms come to the surface of the steel and form a scale on the steel. And that needs to be ground off and cleaned up when you finish the blade. Except if you're doing your heat treating in an atmospheric controlled oven. And that's an oven where the oxygen is pumped out and an inert gas is pumped in. If there's no oxygen present, then you won't get the decarburization process. With stainless steel, there's some other ways you can help reduce that, putting a coating on the steel or wrapping them in a high temperature stainless steel pouch, which is the method that I use, which reduces the amount of oxygen that's available during the heat treatment process, so you get less of that decarburization. Now, there's a lot of manufacturers of steels, and each country seems to have their main manufacturers. Here in America, Crucible Steel is one of the big suppliers and manufacturers of steels that we use in knife making. In Germany, it might be Uddeholm. In Sweden, it's Sandvik. In Japan, it's Hitachi. And most of these manufacturers make very similar steels, although they may call them by different names. But, there's a lot of sources online where you can look up steels and see what their recipe is, how much carbon and vanadium and manganese they have in them, and you can pretty much see which steels are comparable to each other. And, sometimes it's just a trick to find the steel that you want that works best for your application. Everything in blade steel is a trade-off. I mean, we all want the steel that is so hard it will never dull, yet so tough that it could never break, and it will never rust, and just, the magic all-purpose steel. Unfortunately, it doesn't exist. Everything's a trade-off. You trade hardness for toughness, and that's confusing to a lot of people, but the harder the blade gets, the more brittle it gets. And if it's too brittle, you risk a chance of, actually the blade snapping in two or the edge chipping. Toughness is more of the impact resistance and the resistance to breaking and chipping. Allows it to flex a little bit, return to its shape, particularly right down on the edge. Wear resistance is very similar to hardness, how well that edge will hold its edge before you need to sharpen it again. And in practical everyday use, it becomes a factor. Do you want it so hard that, yeah, it's going to hold an edge for a long time, but man, when you do have to finally sharpen that thing, it's going to take you all day. To me, toughness is one of the key factors. I always look at a knife as, what's the worst case scenario? What if I'm somehow stranded in the wilderness and this knife, my life depends on this knife? And my way of thinking is, if a knife gets dull, you can always put an edge back on a knife. I can find a smooth rock and hone an edge on that blade. If the blade snaps in two, it's pretty much useless to me. So I would take toughness over hardness. I may have to sharpen it a little more often, but I'll be able to depend on that blade. And by more often, I mean 440C, as I said, is one of my favorite steels. A good friend of mine, Cliff Finley's a knife maker. His personal hunter he made from 440C. He's used that knife for years. He has field dressed dozens of deer with that knife. He has not resharpened that blade. Only thing he has done is just dress the edge a little bit with a crock stick, just straighten it, the micro edge back out, and that knife will still shave hair. I mean, proper care, proper use, you really should not need to resharpen your knives very often. Just a little dressing the edge is basically all you ever really need. Now, I talked a little bit about carbon steel, what people often call high carbon steel, and stainless steel. There's a lot of misconceptions about that too. Just the terms themselves, high carbon steel and stainless steel, and I have people come to me at shows and, oh, I don't want a stainless steel knife. Stainless steel won't hold an edge. Well, stainless steel and carbon steel are very general terms. There's hundreds of types of each. So when you're saying stainless steel, what stainless steel are you talking about? Are you talking about some Chinese crap that, $10 Wally World knife that's what you're basing your thoughts on stainless steel on? There's many, many, many different types of stainless steel. And you hear the term high carbon steel. Well, all the good stainless blade steels that I use are also high carbon steel, and in many cases more carbon than what people call high carbon steel. And, you know, for instance, you take 1095 as one of the best high carbon steels. Well, 1095 means it's a 10 series steel and it's got 0.95% carbon. 440C stainless that I like to use has 1.1% carbon. So it actually has more carbon than your high carbon steel, although it's stainless. And, you know, I can tell you stainless will perform as well as any high carbon steel, or if not better. Plus you get the added benefit, you don't have all the care and maintenance worrying about it rusting. I mean, just minimal maintenance, just basically keeping it clean and dry. You don't have to worry about it. You know, high carbon steel, yeah, you can let it form a patina, which is, you know, kind of a protective, it's a type of rust actually, but a protective coating. And care gets a little easier, but, you know, in my opinion, as I said, with modern steels are complex alloys. They have all of these elements, and all of these elements were added because they bring a specific property to the steel. And in my opinion, that's just better. Now, I prefer to mirror polish my blades. I think they actually perform better. They look great in my opinion, but they actually perform better. They're, you know, they're really, I feel, is less cutting resistance. They're easier to maintain. If it's got a mirror polish finish, it's just super smooth. You don't have all these little microscopic nooks and crannies for dirt and water to get trapped in. You know, a good stainless blade, you rinse it off, the water pretty much just beads up and runs off of it. You wipe it down, you're good. And if you like to mirror polish, you'll find that some steels polish much better than others. And it's another reason I like 440C. ATS 34, CPM XHP also, you know, just take a great polish, as well as being a very good performing steel. Other steels such as D2, I don't care how much you polish it, it's just always going to have kind of a cloudy finish to it. It's just not going to get that high mirror polish like I like. And you'll find that some steels, sometimes one batch, even with 440C, you know, I've had some batches that polished better than others. Maybe it was a different manufacturer, just a slightly different manufacturing process. I mean, I really don't have an explanation for it, but I know I bought some steel that came from a particular mill run that just polished fantastic, and then, you know, another batch just wasn't quite as great, or wasn't quite as easy to get that high polish. And then finally, there's Damascus steel. And I know, before people start commenting on the video, Damascus, what we call Damascus today is forge welded steel. The original Damascus got its name from Damascus, Syria, where it was believed to be produced. It was a type of steel was really known as Woots, and how they made it has been lost. Nobody really knows for sure how it was made, and yes, it was a very different steel than what we call Damascus today. The modern Damascus was really reintroduced to the market by Bill Moran, who began experimenting with forge welding layers of different steels together. And when all these layers are forge welded together and folded, and layers are multiplied, and then it's ground down, you get these great patterns And just like with the terms carbon steel and stainless steel, Damascus is a very general term. There are many types of Damascus. There's good Damascus and bad Damascus. It just depends on what materials go into it and the skill of the people who forge it. And it is an art in itself to forge weld these steels, get it fluxed right, so that, you know, there's no voids in it. There's some very good Damascus steel. There's a lot of cheap crap that comes out of Pakistan and India and China that, you know, it's just not good stuff. I usually use Alabama Damascus, made by Brad Weiss of Alabama Damascus. And this is actually, for example, this piece is 416 layers of 4 types of metal. And in this case, he starts with 4 layers of 5160 spring steel, 3 layers of 52-100 ball bearing steel, 3 layers of 15N20 bandsaw blade steel, and then adds a nickel alloy to give it some contrast. And he takes those 13 layers, they're forged welded together. So you have this solid piece, 13 layers of 4 types of metal. Then it's folded 5 times. It's hammered out, drawn out, folded over on itself. Every time you fold it, you double the layers. So you had 13 layers, you fold it 1 time, you got 26 layers. Fold it twice, you got 52 layers. The 3rd fold gives you 104 layers. 4th fold gives you 208 layers. And finally, when you fold it the 5th time, you got 416 layers. And there's different ways you can fold this. There's different dies you can use to hammer it out that gives you different patterns. And that pattern actually shows up when the steel is etched in an acid bath. And the acid will react differently with the different types of metal that are in here. The nickel won't etch at all, it won't darken. And that's what gives you the bright silvery lines, is actually the nickel that did not harden. It gives you contrast. Now, for instance, this piece here, when I cut and grind it, that black is going to go away. You're not going to see the pattern clearly like you do here. You really have to hold it in the light just a certain way just to even see the layers in it. But after I get it all ground and finished, then I'll put it back in the acid bath. That will darken down the carbon steels, not darken the nickel, and that'll make the pattern show back up. One of the biggest advancements in modern times with steel was crucible steel came up with the particle metal process, CPM steel. And that was a tremendous advancement in the quality of the steel, where rather than just take these elements, mix them together and, you know, in a molten form and then pour it out, the steel is actually kind of sprayed out. It's hard to explain. It's kind of atomized, and it resulted in a much finer and more uniform grain structure in the steel. And it really was a big advancement in the steel making process. So to kind of wrap up here, I stock many types of blade steels, depending on what the customer wants, or sometimes you want to use a particular steel for a particular application. I've tried many different types. I talk a lot with other knife makers. I've learned a lot from other knife makers who have done a great deal more of experimentation and testing with various steels than I have done, but I've learned from what they've done. You know, you get a lot of hype every year. Manufacturers come out with the new, latest, greatest blade steel. And really, most of it is just hype. of course, if you're making something, you want to sell it, you're going to hype it, you're going to say it's the most wonderful thing since sliced bread. But, even if it is some really great new steel, that doesn't mean the steel from yesterday is no longer any good. If it was good 50 years ago and it worked well and it performed well, it's still good today. And 440C's been around a long time. Gil Hibben was one of the pioneers that started forging 440C back in the 60s when you could only get it in round stock, so he had to forge it to get it into a flat bar to work with. After it became available in bar stock, he really saw there's no need forging this stuff out anymore. So, spring steels and tool steels, the 1080s, the 5160s, they've been around for a long, long time. They worked well then, they still work well now. So, don't get too caught up in all the latest, greatest super steel hype. Every year there's some steel that, people just, oh, this is the end all of blade steels. And most of the time it pretty much just comes out to be hype. Yeah, it's a good steel, but there's other good steels. And sometimes it comes down to, I'm not going to name any in particular. I don't want to slam any manufacturer, but, a couple years ago they came out with some new super great steels that maybe they were just slightly better in some aspects, such as wear resistance, but, it came down to, did you get enough extra benefit to warrant paying 3 or 4 times the price for it? And in my opinion, no. You really have to look at the cost versus benefit, hardness versus brittleness, and sharpening, and flexibility, and impact resistance. All of this goes into making your decision to what blade steel you want to use. I stock many types of steel that I just keep on hand, and I'll special order other steels for, if a customer has a particular type of steel that they want. 440C remains my go-to steel, but, other very good steels that I like, ATS 34, CPM 154, D2 in some applications. I do stock some CPM S30V. I stock carbon steel such as 1095, 5160, 1080. I have some of the Sandvik Swedish steel, the 19C27, 12C27. Usually have a pretty good supply of Damascus in various patterns and thicknesses available. But there's lots of good blade steels. There's lots of sources for blade steels, specialty metals, crucible steel, Admiral steels, where I buy a lot of my steel. You can also get it from knife maker suppliers such as Jantz, Texas Knife Maker Supply, or Pops. So there's lots of good sources. In my opinion, if you're learning, you just want something to practice with, use whatever's available. I mean, just learning to grind a blade, you can actually even do that on wood, just to get your grinds down. But when you decide to really make a good knife, start with some good steel. Anyway, that's my thoughts on blade steels. I hope some of you found this informative and a little bit helpful. This is Mike Carter with Carter Custom Knives. Thanks for watching.